Hi, students. So this is Notes Unit 10, Day 3, things that you need. Oh, by the way, I'm going to tell you, the video is doing something really weird right now. I'm not sure what it is, but we're going to make it through this. You should be able to hear me just fine. So when you see this craziness on the screen, just laugh with me. Okay, so you need your circle notes, the blue page, that's an extra page of notes. You need the white notes that say Unit 10, Day 3. These go together, so you could actually staple them together if you wanted to, that's fine. And then you are going to need two highlighters, and we're highlighting on the blue, so don't use blue, I don't care, but those two colors are good. And then you need your calculator. I'm going to insist that you have highlighters to help you visualize what I need you to visualize. Okay, so most of our notes are going to happen on the blue page, and then we'll jump back and forth to the white page to get some questions for you to answer. Okay, so these are the angle and arc measurement theorems, and it's in an easy format for you to find what you need. Basically, when we get to the worksheet, you're going to find the picture that matches a picture on here, and then it's going to tell you exactly how to work out the problem. On your worksheet, it's going to ask you for why. Your why are the things that I'm telling you in here and the things that we write down. Okay. All right. So we'll be jumping around, like I said, going back and forth. All right, so these first two, I'm going to put stars. These are the main angle questions that you will have, and they're two that you need to memorize. So the first one is dealing with a central angle, and the second one is dealing with an inscribed angle. Based on your vocab that we've had already, you should know what those are. So the rule says for a central angle that the angle is equal to the arc. Okay, so angle ABC is equal to arc AC. So let's put a 50 degrees in here. You've seen me do this on the video notes for the vocab. And then let's put a 50 out here. So visually, you can see that the angle equals the arc. And then we're going to write it in words. Angle equals arc when you have this picture. Okay, next one, inscribed angle. So an inscribed angle has the vertex on the circle and the sides are chords, or sometimes they stop at the center, which is fine. So when you have this picture here, let's pretend that this arc is 60. Okay, so if the angle was at the center, then that would be 60. But because it's not at the center, I want you to imagine that it's at the center and they keep pulling it and pulling it and pulling it. What happens is the angle gets smaller by half. And so when the angle is an inscribed angle, it is half of the arc. The angle is half the arc. So we're going to write that down. Angle is half the arc. Okay, and like I said, these two are very important that you remember what they are. All right, this one I don't think shows up on your worksheet, but it is a very popular theorem in circles. Grab your highlighter, and what happens is we've got this pink angle, and we've got this yellow angle. Okay, notice both of those angles are opening up to arc AD. So what this is telling me is that if this arc, let's use 80, if this arc is 80, then angle B is an inscribed angle, so that means this would be 40. And angle C is also an inscribed angle, which means that this angle would be 40. So the theorem says if two angles are opening up to the same arc, intercepting the same arc, then the angles are equal to each other. That's exactly what that one is saying. All right. Next one. Inscribed quadrilateral. So remember inscribed and circumscribed. Inscribed means the shape is inside the circle. So you do need to know the difference between those. And this is talking about a quadrilateral, any four-sided figure that's inscribed in a circle. It doesn't have to be like a rectangle or a trapezoid. It's just a random quadrilateral. So when that happens, it says opposite angles are going to add to 180. So I want you to put opposite. Opposite angles are going to add to 180. So let's put a 180 in the middle. And let's put some arrows like this. That's showing that angle A and angle C together are going to add 1 to 180. And then let's do a double arrow. like that to show that the double arrows go together. So angle B and angle D are across from each other. They will also add to 180. Okay. All right, we're going to come back to this one. So let's go to this one, and then we'll go and see if we can do any questions yet. So this property, or this theorem right here, is related to this one. Okay, so it has the same rule as what's up here. If you can see down here, the angle is half the arc, the angle is half the arc. So what happens is, this is an inscribed angle. They actually consider this an inscribed angle because instead of a chord, it has a chord. Instead of two chords, it has a chord and a tangent, but the vertex is still on the circle. So this is taking a chord with a tangent, and we still have the same properties. The angle is going to be half the arc. So I'm going to give you an example. Let's say angle 2 was 40 degrees. Now, you guys know from being in geometry for as long as we've had that angle 1 is supplementary to angle 2. So that means angle 1 is 140. And there's no doubt in my mind that you should know that. Okay, that you shouldn't know that. Those two are going to add to 180. So remember, this is 360. Okay, so the angle is half the arc. That means this arc over here has to be 80, just like we did up here. The angle is half the arc. The arc is bigger, the angle smaller. The arc is bigger, the angle smaller. And then if this is 140, remember the angle is smaller, the arc is bigger. This has to be 280. Well, guess what 280 plus 80 add up to? 360. Okay, so it follows the same rule as the angle is half the arc. 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 Okay. All right, let's go to the, let's go to the white page. We'll come back. All right, these first problems, there are some things on the white page that are not on the blue page that you're going to have to come back and look at, and this is one of them. This does not show up on the blue page anywhere. It kind of does a little bit, but it's not specifically on the blue page. So you need to know that you're going to need these on the worksheet. The theorem says, if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. So if this is a right angle, then this is the reason why. It kind of, what I was talking about, it kind of goes off of this. It's a very popular theorem, okay? The angle is half the arc. So work with me here. Look at the right angle. This right angle is opening up from here to here. And it is opening up to a semicircle. How many degrees are in a semicircle? 180. So if this is opening up to 180, that means the angle is half the arc. That has to be 90. So it is, in a sense, using this theorem right here, the angle is half the arc. It's just going ahead and completing it and making it a triangle. Okay, so the way we would do this problem, now that you know it's a right triangle, all three angles are going to add to 180. Or the shortcut, these two angles are going to add to 90. Okay, and we would finish that out, 90 minus 55. And then divide by 2. And we get x equals 17.5. Okay, so question number 2 is the same thing. Solve for x. Instead of me giving you the right angle, you should know, okay, this is what we're looking at. This is an inscribed angle. It is opening up to the diameter. So this is 180 degrees from here to here. So that means this has to be 90. So very easy. X equals 45. Okay. All right, question number 3 is using this theorem right here that I just showed you. So that means these two angles are going to add to 180. So this one is 80. These two angles are also going to add to 180. So this would be 130. Okay, angle G is 130. Angle H is 80. Go ahead and do problem number 4, and I will ask you a question about it. Okay, so you should have got x equals 133, and you should have had y equals 60. Opposite angles are going to add to 180. Opposite angles are going to add to 180. X is 133. Y is 60. Okay. All right, let's go back to the blue sheet. Okay, the next theorem we're going to look at, we're going to go to the back and take care of these first. So this one says if AB is tangent to circle C, in other words, AB is a tangent and it's touching and we've got a radius drawn, then this makes a right triangle. Okay, so this will make a right triangle. A lot of times you will see Pythagorean theorem, find the radius if a squared plus b squared equals c squared. So that is a neat theorem to have, but it also, look at it. This is the same picture as this one right here. Okay, if I were to stand this up, the angle is half the arc. So it just so happens that this is standing up, this is 90. So if I were to extend this out, this is 180, this is 180, this is 90. It's the same thing. So we've had two theorems now that have stemmed off of the second theorem that's on the front. This one is not going to show up on your worksheet, but it says if you have two tangents from the same external point, then these two pieces are going to be equal. We call this the ice cream cone problem. So those two pieces would be equal, but I don't think you're going to see that on worksheet number 50. Okay, before we flip to the front, if you forget your formulas, they are right here. This is the one I like using. Go ahead and circle that. Okay, but both of your formulas are here. We will not use this, and we will get to this later on. Okay, so now we have the ones where we have to do some calculations. So this one here is the intersecting chord. So this is when you have them intersecting on the inside. So let's put inside. Okay, this point is not the center. Okay, if it were the center, we would be looking at this. Okay, so these are not the center. The angles are not going to equal the arc. So what it is when the two chords or secants or whatever are intersecting inside, it's like an average. Okay, so if I'm going to find the angle. So if I wanted to find angle 1, grab your highlighter. Now, those are the arcs that angle 1 are opening up to. So I'm looking off of angle 1, and what I'm going to do is I'm going to add these two arcs together and divide by 2, and that's just how the theorem works. Okay, so it says angle 1 is arc AB plus arc CD, but then I'm cutting it in half. I don't like the way that's written. I like this. Okay, where this is your A and this is your B. So when you do these problems on the worksheet and it asks why, all you have to do is give me that equation and work it out. Okay, so add the two arcs together, divide by 2. That gives you angle 1. How do you get angle 2? It's a linear pair. So let's write that down here. Linear pair to get angle 2. Okay. All right, go to your white page. All right, so I'm telling you here that it's not a central angle, and I want to find angle 1. I'm going to give you the formula, and you are going to do it. So the formula is the two arcs, and my two arcs are right here. Okay. And so you're going to work this out. It's going to give you angle 1, and then it's a linear pair to get angle 2. Go ahead and get those two answers. Okay, so this is what it looks like. 30 plus 60, or 60 plus 30, I don't care, equals 90 divided by 2, and then that equals 45. So that means angle 1 is 45 degrees. Angle 1 is 45 degrees. Okay, angle 2 is supplementary to it, and so you subtract that from 180 and you get 135. All right, now question number 9, example number 9 is the same thing. Go ahead and try it, and I'm going to ask you a question about it. Okay, these are my two arcs that I'm looking at. And I want to find angle 3. So it's going to be 106 plus 174 divided by 2. 106 plus 174 is 140. And divide that by 2, we get 70. Okay, so that means angle 3 is 70. What is angle 4? Angle 4 is going to be, wait. No, this is 140. I'm sorry. How did I do that? What, did I divide by 2 too many times? 106 plus 174 divide by 2. I don't know how that happened. Is 140, not 70. Good gracious. Sorry about that. Is 140. And so then this one is 40. It's a linear pair. All right, so angle 3 is 140. Angle 4 is 40. Okay. Now, I want you to think about this. If they put an X right here and they gave you this number, you're going to make an equation out of it. You would say 140 equals X plus 106 over 2. And you would have to multiply by 2 and then subtract. So you're going to have problems like that on the worksheet, but I will help you with that. Okay, so don't stress out about that. If the X is here, where my finger is, you would have to start with the 140 equals A plus B over 2. Okay? All right. Let's go down here and pick up these problems here. So these are working off of this one here. Remember, the angle is half the arc. The angle is half the arc. The angle is half the arc. And on your homework, on your worksheet, you look for a picture that matches the blue sheet and it tells you what to do. Except for these. These are not on the blue sheet. Do we need to write that? Okay. These are not on the blue sheet. Okay. So we have all right, we have this arc is 150. So remember what I said. The angle is half of the arc. The angle is half of the arc. The angle is half of the arc. All right, so if this is 150, then that means angle 1 has to be 75. Okay, the angle is half the arc. Now, there's two ways to get these other answers. I could go ahead and get angle 2 and then get the arc. Or I could go ahead and get the arc because you guys know that this adds to 360. So if I did 360 minus 150 and I got the arc, then I would cut it in half to get the angle. Two ways to do it. Okay, I like getting the angle than the arc, but it doesn't matter. So this is 105 because those are going to add to 180. The angle is half the arc, so that means this arc has to be 210 degrees. So this arc, 210, angle 1, 75, angle 2, 105. Okay, you're going to do number 6. Go ahead and find all these answers for number 6, and then I will ask you a question. Okay, So if this angle is 130, this arc is 260. Arc PXR is 260. If this is 130, that means this angle has to be 50 because they add to 180. So angle 3 is 50. And the angle is half the arc. So that means that arc has to be 100 degrees. All right, next question with some algebra. And I'm going to help you with this. That if you will remember what happened here, it helps you with the algebra. What did I have to do to the 50 to get the 100? What did I have to do to the 50 to get the 100? I had to multiply by 2. Which one of these are you going to multiply by 2? This one. I have to multiply this one by 2 to get the arc. So I'm going to say 2 times 5x equals 9x plus 20. 10x equals 9x plus 20. And x equals 20. So let's circle this and put we need 2 of this. All right, so you need 2 of that to equal that. All right. Blue sheet. The only thing we have left now is to cover these 3 at the bottom. So these 3 all go together. Take your highlighter and let's highlight all 3 of these boxes together. The reason we're highlighting them together is because they use the same formula. So what we have is 2 secants meeting at a point. Now this time the point is on the outside. Point is on the outside. Point is on the outside. So remember, when the point was on the inside, we use this formula right here. When the point is on the outside, we're going to use a different formula. And you can kind of see what's happening here. But I'm going to give you an easy way to remember. And this will be your reason why when you do the worksheet. So the formula is the angle is, I'm going to say 1/2. We are going to have a big arc, and we are going to have a little arc. Okay, so it's going to be 1/2 the big arc minus the little arc. This is where your 2 colors are going to come in handy. So all of my big arcs, I'm going to highlight pink. Okay, so in this picture here, we're looking at the intercepted arcs. This is my big arc. In this one, we're looking at the intercepted arcs. This is my big arc. And in this one, we're looking at the intercepted arcs. That is my big arc. All right, little is going to be in yellow. This is my little arc. This is my little arc. And this is my little arc. Every single time we have these problems where you're looking for a point on the back, it's going to be 1/2 big minus little. 1/2 big minus little. Okay, so that is it for the blue page. We will cover the rest of this tomorrow, or the next day I see you, sorry. So on your white page, go to example number 10. Okay, so all 3 of these are dealing with that formula that I just gave you. So take your first color that had your big. Here's big. Here's big. And here's big. Take your other color. Little. Little. And little. Okay, it's 1/2 big minus little. So angle 1 equals 1/2. The big is 157, big. The little is 25. Angle 1 is equal to 1/2 big minus little. Now what you're going to do is you're going to subtract and then divide it by 2. Okay, so 157 minus 25. And then divide it by 2, and we get 66 degrees for this one. Angle 1 is 66 degrees. 1/2 big minus little. All right, this one. Now, pay attention to this. Do you notice there's no number on the pink? So you're like, Ms. Arnsberger, how can I do the formula? Because right now, this is what I've got. Angle 2 equals 1/2 big minus little. And I don't have a number here. But what do you notice about what's colored in this picture? The whole circle is colored. Is the whole circle colored over here? No. Is the whole circle colored over here? No. But the whole circle is colored over here. So we have to actually do a little bit of calculation. And if I take 360 and subtract the 82, then that's going to give me 278 degrees, which is the pink. Okay, so this is 278 degrees right here. Some students will get confused and they will try to put a 360 right here, and that is not correct. You use 360, but it does not go in the formula. Okay, go ahead and get that answer for me. All right, you should have had 278 minus 82, and then divided by 2, and we get 98 degrees. Angle 2 is 98 degrees. All right, number 12. Formula is going to be angle 3 equals 1/2 big minus little. Go ahead and get that answer for me. And you should have had 15 degrees. These angles are not going to be very big because they're outside, and I don't think they're ever going to be really that obtuse. They can't be. So you might get some really small numbers, but I don't think you're going to get any really big numbers. Okay, good. Now, once again, if I were to throw a variable right here where the 20 is, okay, that means you would have a number here for the 3, and you would have an x right here. And you would have to do some algebra to figure that out, which you might have. Okay. Would you please do number 13? And I'm going to ask you a question. So I'll tell you, number 13 goes back to this one. Okay, go ahead and do number 13. Okay, so angle 1 is just supplementary to the 112. So that's going to be 180 minus 112, which is 68. And then remember, the angle is half the arc. So I need 2 of these. So 2 times 112 is 224. And then 2 times 68 is 136. Guess how you can check that and know that it's right? 136 plus 224 should equal 360. And you know 100% that you have that right. These are going to add to 180. These are going to add to 360. That should make sense to you. All right, number 14 goes off of, so they're intersecting inside the circle, but not at the center. That is going to go off of this one. Okay, go ahead and do number 14. All right, let's see if you got it right. So we're going to say angle 1 equals, and it's going to be a plus b divided by 2. Really, it's 1/2 a plus b, but I like the divided by 2. So 87 plus 22 divided by 2. Be sure you hit equals before you hit divided by. 54.5. So angle 1 is 54.5. How do I get angle 2? I subtract that from 180. $125.5. Awesome. All right, so here's a problem where we have the x here instead of here. Okay, so I want to show you. First of all, we got to get the formula. So you look at this picture. This is like this one here. Okay, so look at the picture. It's got a point on the outside and it's got a tangent and a chord, which is this one here. Still, it's 1/2 big minus little anytime that point is on the outside. So the angle is 72. So I'm going to put 72 equals 1/2 big minus little. So the only difference was I don't know what the little is, that's my x, and I do know what the angle is, and it's 72. So you can distribute the 1/2, or you can multiply both sides by 2, which is what I prefer to do. Multiply both sides by 2, that gives you 144 equals 200 minus x, and you're just going to do a little algebra to figure out what x is. So what I would do is I would add x to the right to make it positive and subtract 144 from the left. Add x over to move it over here to make it positive, and then subtract 144, and you should get 56 degrees. And you could double check that by adding these two together, dividing by 2, and it would give you 72. All right, your notes are done. Make sure you go in and mark this video as done so it goes off of your to-do list. Thank you, students. Stay awesome.